So far, we've only considered optimizing the fares for a single route. In this video, we'll change our optimization formulation to include connecting flights. Now, instead of just being able to go from JFK in New York to LAX in Los Angeles, let's suppose that the plane stops in Dallas at the Dallas-Fort Worth Airport. Then passengers can fly from New York to Dallas, Dallas to Los Angeles, or they can still fly from New York to Los Angeles by flying through Dallas. So how does our optimization problem change? We now have 6 types of seats that we can offer. The original 2 types, regular and discount from New York to LA, and then 2 types for the new flights, New York to Dallas and Dallas to LA. We know the price of each type of ticket and the forecasted demand for each type of ticket. We also know that we have a capacity of 166 for each leg of the trip. So what are our decisions now? They're the number of regular seats to sell for each leg of the trip and the number of discount seats to sell. So in total, we have 6 decisions to make. Now, what's our objective? Like before, it's to maximize the total revenue. This is the sum of the price of the ticket times the number of seats of that type we sell. And like before, we have 2 types of constraints, capacity constraints and demand constraints. For the capacity constraints, the airline shouldn't sell more seats than the capacity of each plane. We need 2 capacity constraints here, one for the New York to Dallas leg and one for the Dallas to LA leg. We also need 6 demand constraints, one for each type of ticket. The number of seats sold should not exceed the forecasted demand for each type. Lastly, we can't sell a negative number of seats, so we have our non-negativity constraints to prevent the variables from being negative. Let's now go to LibreOffice and adjust our formulation to solve this bigger problem. In LibreOffice, go ahead and open the file Week 9 Airline RM Connecting.ods. In this file, I've set up our data, our decisions, our objective, and our constraints. Our decisions again are highlighted in yellow. We have a decision for each type of seat on each flight. Our objective here is the spot in blue. To build our objective, we'll use the sum product function. So type equals, and then sum product, and in parentheses, select all 6 prices, type a semicolon, and then select all 6 decisions. Close the parentheses and hit enter. We see here, like we did before, that we have 0 in our objective, because right now we're not selling any seats. Now let's create our constraints. The first constraints are capacity constraints. The first is the capacity on the leg from New York to Dallas. The left-hand side should be equal to the seats from New York to LA plus the seats from New York to Dallas. The sign is less than or equals, and the right-hand side is 166, the capacity of our aircraft. Now we need to build the capacity constraint from Dallas to LA. The left-hand side is equal to the seats from New York to LA plus the seats from Dallas to LA. Our sign is again less than or equals, and our right-hand side is 166. For the demand constraints and the non-negativity constraints, because we have 6 of each this time, we'll actually make them in a more efficient way than before. So we just have a note down there that we need to remember to add these constraints. So now go ahead and in the Tools menu, select Solver. We need to first fill in the target cell, which should be the objective. Make sure that Maximum is selected. Then, in the Changing Cells box, select all 6 decisions. Down in the Limiting Conditions, let's now build our constraints. For the Cell Reference column, let's start by selecting the left-hand side of the 2 capacity constraints. The operator should be less than or equals, and the value should be the right-hand side of these 2 capacity constraints. Now let's make the demand constraints. In cell reference, just directly select the 6 decision variables, make sure the operator is less than or equals, and for the value, select the 6 demand constraints. This was a bit easier than what we did before because we didn't have to type them all out in our spreadsheet. Now let's do a similar thing for the non-negativity constraints, where in cell reference we select the 6 decisions. The operator this time should be greater than or equals, and for the value just type 0. Make sure in options that the linear solver is selected, and go ahead and hit solve. The solving result should say, solving successfully finished, result 120,514. This is our total revenue. Go ahead and click Keep Result. And let's take a look at our solution. So we see here that the optimal solution is to sell 80 tickets for the regular price from New York to LA, 0 of the discount price from New York to LA, 75 of the regular price from New York to Dallas, 11 of the discount price from New York to Dallas, 60 of the regular price from Dallas to LA, and lastly 26 of the discount price from Dallas to LA. We saw here that we could pretty easily solve a more complicated problem in LibreOffice that we probably couldn't have solved as easily by inspection.